Welcome back, and we're going to go for something slightly different this week. The Intermediate Maths Challenge paper is a great paper. We've had quite a few questions from it already, but more notably, it's a really good preparation for GCSE, practice those harder questions. It's also a good paper for those that don't do A-level maths or similar regularly, so it doesn't involve a lot of very hard maths, it just involves some thinking. And the whole paper is definitely worth a go. So what I'm going to do is I'm going to split the paper into 5 chunks. We're going to basically do the easier questions first and then build up to the harder questions at the end of the week. So let's look at the paper itself. So the paper itself is typically taken by those in years 9, 10 and 11, so age 13 to 16. And as I've said before, a really good preparation for GCSE because it asks the questions in a slightly different way to check you've understood. So if we look at the scoring system involves an increasingly difficult set of questions whereby the later questions not only award more marks but also award negative marks for guessing, so obviously avoiding you just filling in blanks and giving the question a go without proper thought. And indeed some of the answers are designed to not trap you but check you've understood the question itself. The real exam has a time limit of 60 minutes and the scores, well, a very good score, and typically around gold level is 75 to 80. Over 100 is excellent, and so here we're talking about being entered to the higher levels of the following competition. And just to state the obvious, it's a non-calculator question. Now I'm only going to do this on day one, so the way I'm going to run it is day one we're going to have all 10 of the easier questions, so it's roughly about a minute each that I want you to do this in. My times here are pretty rough, but they're a reasonable guide because you really want a bit of extra time on the harder questions. And as you'll see, they start easier, but that doesn't mean they're easy. Anyway, what I recommend is I'm going to put up the video, pause it quickly, give yourself a minute, no more than a minute, see if you can get the question done. If you can, well done, and let's see if you can get all 10. Just in advance, I will say there's one of these questions that I think might trip a few of you up. Question 1 coming up in 3 seconds, so everyone ready? 3, 2, 1, question 1. Okay, so nice easy one to start. 6 minutes, there are 60 minutes in an hour. 6 over 60 is 1 over 10, which is 0.1, so your first answer is B. Next question in 3, 2, 1. All right, so we want the total amount of crumble that we're making, so I'm going to add up the crumble that I need, which is 100, 50 and 50, which is 200. 2.5 times that is add another 200, add another 100, and that gives you 500 grams. That's not one of my answers because it wants the answer in kilograms, so therefore this first one is a 0.5 over kilogram. Next question in 3, 2, 1. So these are pretty common questions. I like you to deal with big numbers. Again, you don't have a calculator, it's just an understanding of digits, units, and where you are in the number system. So for this one, I'm doing 3 million eggs divided by the 20,000 nests, cancel my zeros, gives me 300 over 2, which is 150, so it's answer B. Still hasn't got massively difficult. It does get more difficult, trust me. Next question in 3, 2, 1. Okay, so this was another estimate question. You were digging a tunnel for 5 meters a day, 2 kilometers overall, so 2 kilometers is 2,000 meters, divided by 5 is going to give you 400. So on these questions, you do need to be a bit more careful because you need to check which one is closest rather than giving you a precise answer. So it's not A and B because that's definitely not near a year. It could well be C, but it's over a year, not under, so it's probably not C given where D is. And equally, it's definitely not closer to 2 years, so it's definitely not E, which by default leaves D, and so therefore this one is going to be D. Next question in 3, 2, 1. All right, so this is a nice question which involves you moving or doing something to both numbers, which leaves the difference the same. So if we look at what we've got 10,006 minus 8,008. So A is taking away 1 from the 8,000 number and adding 1 to the 10,000. So therefore my difference is not going to be the same. So it's not A. B is multiplying both numbers by 10. So therefore my difference would also be 10 times larger. So it's not B. Similarly, if we look at D, D is divided by 100, give or take. So therefore it'll also divide my difference by 100, so it's definitely not D. Similarly for E, I'm dividing both numbers by 2, so my difference will divide by 2 as well. So not just by default, but actually if we look at C, C takes away 6 from the 10,000 number, takes away 6 from the 8,000 number, so 6 from both means my net difference is the same, so my answer is going to be C. Nice little question involving understanding the difference of operations to two different numbers. Next question, 3, 2, 1. So again, still warming up, I think, for these questions, but it's a nice question to be able to do quite quickly. So 20% is a fifth, and 3 times 4 is 12 plus 3, which means 3 3/4 is 15 over 4. Cancel top and bottom with by 5, which gives me 3 over 4, and that is answer D. Next question in 3, 2, 1. Okay, so just as a warning, so this is the question that I think quite a few people would have got wrong, because it's easy to try and work out a solution without thinking about what the full question says to you. So what have we got? Well, we've got a function machine which does this. So it takes the value, divides by 3, minus is 10, divides by 3 again, and takes away 10. So if I rearrange this, so I'm just going to quickly rearrange this down. Here, I get the input as a function of the output. Now, the key to this question is not to put 0 in to get the smallest number I can, it's to realise I want the output to be the smallest positive integer. And the smallest positive integer is going to be 1, so therefore put 1 into this equation above, and that gives me 129. So the answer to this one is not D, which I'm guessing quite a few people might have got, but the answer to this one is going to be E. Nice question. Next question in 3, 2, 1. Non-calculator makes this more difficult, because clearly in a calculator it's quite easy. So 40% is 2/5, 50% is a half, multiply that by 60, and that gives you the answer of 12. Then I've got 50%, which is a half, 60%, which is 3/5 of 17. So what's nice here is, although it doesn't cancel out, the numbers aren't too bad. So 3 70s are 210, divide by 2 times 5, which is 10, which is just going to give me 21. Then the question says, what are the difference between these two numbers? So 21 minus 12, well, that is going to give you the answer of 9. So this one is answer A. Next question in 3, 2, 1. All right, so they're definitely starting to get a bit harder now, aren't they? So this one is really testing your understanding of the idea that if you divide by a larger number, the end result is smaller. So the way to approach this is to think that x is larger. So in your head, you could have 20, 23, or you could double the number. But point is, x is going to be a number that is bigger. So if we then go through step by step, so a bigger number divided by a smaller number gives you a number that's greater than 1. So A is greater than 1. Now, B kind of depends on what number you've chosen. So if you take the example of 3,000, then 2022 divided by a number which is a little bit smaller, it still gives you a number that's less than 1. Again, not in all cases, but for most integers that are greater than 2022. C, not dissimilarly, so I've got a larger number divided by a small number, so C is also going to be greater than 1, but it's also greater than A because x plus 1 is greater than x, so therefore I'm starting with a larger number that I'm dividing by 2022. D, very similar to what we said with B, so D, I'm taking a number and dividing by a bigger number, so that's a number that's less than 1, and E is definitely a number that's less than 1 because I'm adding 1 first. So really, I could definitely eliminate A and C because those numbers are greater than 1. Then the question is, which is greater, B, D, or E? Well, as discussed, if I divide by a larger number, my result is a smaller number. So E is going to be smaller than D, which is smaller than B. So therefore, my answer for the smallest number is going to be E. Nice, but pretty tricky question. All right, next question up in 3, 2, 1, now. All right, nice little question to finish today. So again, this does get harder over this week. I can assure you it gets notably harder than even this question here. You have 100 rectangles, but they're each paired up. So you have 50 lots of this thing here. Now, for the ones in between, I don't have, and I've sort of tried to estimate down here, I don't have the overlapping parts, which is this bit here and this bit here. So the repetition is the 2, the 1, the 2, the 3, and the 4, which gives you 12. I've got 50 of those 12s, which gives me 600. Then I add on the edges, which I've tried to highlight here in red. And so I add these two ones on here. So therefore 600 plus 1 is 602. And my final answer today is going to be C. If you got all 10, well done. Not the most difficult questions, but also not the easiest questions. As I say, they get a little bit harder from tomorrow. So come back tomorrow and let's finish the whole paper. As ever, do like the video, subscribe, and any questions down below. Thanks all.